All right, welcome everybody. I am Lisa Dilks. I'm a professor of practice at the Connolly Alexander Institute for Data Science, or as you may know us, CAIDS. And it is my pleasure to introduce you to our opening or beginning of Love Data Week keynote address. And so I want to just real quickly introduce our guest speaker, Dr. Greg Matthews. He's an associate professor of statistics and the director of the Center for Data Science and Consulting at Loyola University Chicago. Not the Loyola next door, but likely affiliated. Dr. Matthews earned a PhD in statistics from the University of Connecticut. Prior to this, he spent 2 years in the, quote, real world in a direct marketing department building predictive models after he received his BS in actuarial science and MS in applied statistics from, and I don't know if I should say it with the Boston or Massachusetts accent, Worcester? Okay, I butchered it. Worcester, I know I'm not going to get it right, Polytechnic Institute. He also completed a 3-year appointment as a postdoctoral research fellow at the University of Massachusetts Amherst. His research interests include statistical disclosure control, missing data methods, statistical genetics, and statistics in sports. He runs the website Stats in the Wild, which is a blog about statistics and its application in the real world, aka the wild. A lot of the content is about sports, though any topic related to statistics, basically anything could potentially show up. He is also an artist, and his direct quote, favorite thing in the entire world is giving his talk about data art. So he joins us today to do just that. So in Beyond Data Visualization, Data Art, he's going to give us an overview of the emergence, key moments, and examples from the history of data art, along with the presentation of selected works demonstrating how data can function as artistic material beyond just visualization. So please join me in welcoming Dr. Greg Matthews to Love Data Week.
I love giving this talk. All right, so as she said, I'm Greg Matthews. I am a statistics professor, and I married a woman who was an art student, and over the course of our relationship, she got me hooked on art. And I'm going to tell you a little bit about that history. I'm going to talk a little bit in the beginning of this about sort of why I feel data art was an inevitable art form, and then I'm going to go through a little bit of the history of data art up through like modern day. What are we doing right now? Ending with like at the very end of last year. So I made these. These are from my Fitbit data from like 10 years ago. But you got to promote yourself, right? Okay. So I'm going to start by talking about how I think art is garbage. I'm then going to talk to you about how art is not garbage. I'm going to talk to you about context, technology, and about how the context and technology together makes data art inevitable. And then I'm going to talk about the history of data art, and then I have the shameless self-promotion bit at the end where I show you the art that I've made, because you got to be your own champion, right? Okay, so I don't have a degree in art. I'm not an artist in any classical sense of the word, but aren't we all really artists deep down? Think about that, it's deep. So I very clearly remember thinking about how like this idea that art is garbage. Think like you go to an art museum and you see Jackson Pollock. He's literally just dripping paint on a canvas. You're like, this is ridiculous, I could do this. There's also like famous white on white paintings. Ridiculous, right? Why is this there, okay? So over the course of 5 or 6 years, my wife slowly changed my mind. And she changed my mind not only about whether art is garbage or not, but like what is art? She changed my mind about that too. So art is so much broader than just making pretty things on paint on a canvas. But I think, at least I can speak with my own experience, when someone was like, what is art? You think about like medieval paintings of like biblical scenes, right? And that's what's in sort of like all the famous pieces of art that you can name, or like that people can name sort of. If you went to someone on the street and you're like, name a piece of famous art, they'd probably say something like the Mona Lisa, or they would name some painting. This is a very narrow view of art as just paint on a canvas, right? So I want you to, it took me a while to do it, but I'm here to say, you skip all those steps, just stop thinking like that. Art is much broader than that. And beyond the visual appeal of the work, we need to consider the context, history, and the intention of the work. And here's where I make a comparison here with statistics. If we have any statistics people out there, this will make sense. If not, it's not going to make any sense. But there's two main schools of thought in statistics. There's Bayesians and frequentists. And the main difference is that Bayesian statistics relies on prior information. You define priors. There's context to the data in which you've collected. In frequentists, they just collect data and they only analyze the data. There's no notion of a prior in frequentist statistics. And I want you to be a Bayesian when you evaluate art, right? You can take a piece of art, you can take the same piece of art, and let's say you could theoretically copy it, and you could have one of those pieces in, the year 200 and another piece right now, and they mean completely different things because of the time in which they were painted, right? So context is a really, really important thing that I want you to think about when you're thinking about art, okay? So let's talk about what is art, the deep questions. So my working definition of art is, and I've stolen this blatantly from a bunch of people, it's something that causes a reaction in the viewer. And this is intentionally broad, right? It's not paint on a canvas or it's not restricted to a medium. It's anything that causes a reaction in the viewer. And art responds to, reflects on, and critiques the world in which it was made, okay? So there are famous works of art where they're literally, from the Dada movement, there's found art, where Duchamp famously took a urinal, put it on its side, and said, hey, this is art, okay? But the context is what makes it important. You don't have to like it, but it's the context that makes these things important, and it certainly causes a reaction in the viewer, okay? It's about intention, right? A stop sign is not art, but if I take that stop sign and I do something intentional to it and display it in such a way where I'm saying this is art, that same piece can become art. It's time to wake up from my nap. I took a big old nap yesterday. Okay, all right, it was awesome, I'm on vacation. So here's the big question to start. What's the difference between data visualization and data art, right? Because a lot of you have taught statistics classes or quantitative classes before, and you're teaching data visualization. And so I'm going to make a distinction here between data visualization and data art. I need to define what that is. So data visualization, the objective is explicitly and usually exclusively functional. When I'm doing something that is data visualization, I'm doing so where I want to convey information to a viewer. I'm going to have labeled axes. It's going to be very, very clean. I'm not necessarily worried about the visual appeal, how visually appealing it is as a primary goal. Okay, data art can be functional, but it's never the only objective, right? Data art is not. You can't just make a histogram. Well, you could just make a histogram and call it art, but usually when you're making a histogram, you're not just saying, it's not art in any sense of the real word meaning of art, right? So here's my really condescending, you're gonna love this slide. Data visualization answers a question, data art asks a question. Hashtag deep thoughts. Look right at the camera. Perfect. Okay. This statement is kind of like jokey joke, but also I really think it's a good way to think about this. Data visualization, you're trying to do something so that you can answer, you're trying to summarize data in a way that you can answer something about the data set. When you look at a raw set of data, right, it's just a whole bunch of numbers. Data visualization helps us answer questions about that data set. Where's the center of this data set? How much variability is there? Okay? Data art, I think good data art is you're making some art and it makes the viewer think about something and it makes them ask questions about society or big questions. Okay? Hashtag deep thoughts. Okay, so now we're going to talk about context. So the whole first part of this is I'm trying to convince you why data art was an inevitable medium, okay? There's going to be two things here. One is context and one is technology. Those are the two main themes here. I'm going to combine those things and say data art naturally falls out of these things. The first is context. So here are three famous works of art. How many people here know what these works of art are? Most of you know what these things are? Okay, so we have some familiarity with art. I usually give this talk to undergrads in college, and they haven't got a clue what this stuff is. But this one all the way to your left is The Fountain by Marcel Duchamp. It's from 1917. The middle one is Campbell Soup Cans by Andy Warhol, and on the right is the Jackson Pollock that I was sort of talking about. So the Duchamp one here it's literally it's found art. It is called The Fountain. It is literally a urinal that he bought at a store, flipped it on its side, and he signed it R. Mutt 1917. You don't have to like this or think it's good art, but you have to think about when it was made. And so this was made in 1917. In 1917, what was happening in the world was there was mechanized war, right? And people were still fighting with horses. World War I was absolutely atrocious. I watched All Quiet on the Western Front on Netflix, and I think about it every day. It's terrifying. The world was insane. right, people were coming up out of trenches and running at each other, and they were getting gunned down by machine guns. Chaos was literally everywhere in Europe. And so he was part of a movement called the Dada movement, where they were intentionally being absurdist because the world they lived in was absurd. And so you don't have to like that, but you need to think, but that has very different meaning in 1917 in France than it does if we put a urinal here right now, right? And you don't have to like it or think it's good, but you have to understand like when it was made and where it was made, and that gives it way different context, okay? The one in the middle here, these are Campbell's soup cans. Andy Warhol didn't even paint these himself, right? Both of these first two examples are art that was not even made by the artist, right? Andy Warhol was paying people to silkscreen these things. He was just coming up with the ideas. But the whole point of this is that this was being made in the 60s, and the idea of these, Warhol's whole thing was this idea of repetition gives things meaning. He was painting, he was like creating prints of celebrities. Like he's famous for the Marilyn Monroe prints. He's famous for prints of Mao, the Chinese leader at the time. And there's a lot of similarities between celebrity and branding, right? It's this idea that you repeat things over and over again, it gives them meaning. And the Campbell soup can had meaning to him from his childhood. And so that's the idea of what he was doing. And this was being done at a time where like branding was taking off like it had never, like you couldn't brand in 1910 the same way you could in 1960s because of technologies like the television, right? And so he's reflecting on the period in which he is creating his art, right? And that's like his whole thing was this idea of repetition gives things meaning. And then you have abstract expressionism. This is from before, this is in the 1950s. And the idea of abstract expressionism isn't necessarily the final product. It's about the event that created it. So Jackson Pollock's whole thing was he would create these drip paintings. And the way he would paint is by laying these canvases out on the floor, and he would drip the paint onto it. And so this was the motion that he was making ended up creating these works. And so it's not necessarily about the finished product, but it's the whole context, the whole context in which it was made, which includes the process that it was made. Not necessarily the time in which it was made, but the process that was used to make this is the context here, okay? So it's really important to think about the context in which something was made, like the time and the place and who made it. And depending on all those things, you're gonna have different outcomes, okay? Hold on to that thought for a second. We're coming back to it. So context is important when you're making art, okay? Let's think about technology and how technology has affected art, okay? So if you go to any museum and they have a lot of like stuff from the 1500s or earlier, a lot of these paintings, what you'll notice is that there's very few paintings that have the color blue prominently displayed in these artworks from before like the 1700s. The reason this is true, or the reason this occurred was because the color blue, the pigment blue, was very expensive to create prior to the 1700s. And so if there's blue in a painting from that period of time, it meant that someone had a lot of money who commissioned the painting. So blue becomes this color that has a meaning of royalty or wealth, right? Because of the scarcity of it and how expensive it is to produce. In 1706, this chemist, Heinrich Biesbach, figures out a way to make the color blue much, much more cheaply. And so blue in these artworks explodes, okay? And this is right around the time where, or just after this, in like Japan, there's the waves, right? That's all because they were able to make blue pigment easily. It got exported to Japan. And there's a fun side note here that I don't get into, but go down the rabbit hole sometime. The discovery of this blue color in the early 1700s, Newton and Leibniz, the fathers of calculus, have a whole bunch of hands in this because at this point in time, Newton was studying like light and color, and a lot of this was happening around the same time as the color blue was discovered by Heinrich Biesbach. And so there was even, I think, correspondence between them. And so just go down the rabbit hole. We don't need to get into it right here. So that's, you see blue showing up in paintings, in art. That's technology affecting the art. Other examples of this include things like tubes of paint. Prior to the 1840s, or prior to probably the early 1800s, what you'd have to do is you'd have to mix stuff in your studio, and then you would paint in a studio. Someone finally figured out how to put paint in tubes, and this meant people got to go outside and paint. And so because of this change in technology, all of a sudden you see the rise of Impressionism. People are painting outside. They're painting the light outside, and they were never able to do this in the same sort of volume or scale that they were able to do before because of the technological advancement. The same thing around the same time, you have photography. With photography, you get a real-life impression of what you're seeing in the real world, right? You get an impression of reality. And what this means is that painters no longer need to paint. There's no longer a necessity to paint portraits, right? Because we can reproduce this with photography. And so the types of things that people start painting drastically changed with the invention of photography, because you don't need to paint portraits anymore to figure out what someone looked like and to keep a record of the past. So these are examples of technology affecting art. And then, which is very relevant to this particular talk today, you get computers. So computers, they start to show up in the 1950s, like post-World War I, post-World War II, and then you get personal computers in the 70s. What's interesting about this early computer art is a lot of people who had access to the early computers to make computer art were mathematicians and physicists, because that's where they were putting the money into these research centers. So these massive, giant computers, they were being put in research facilities, and it was usually for mathematics or physics. So a lot of the early people who were making art, well, I snoozed it instead of stopped it. So a lot of the people who are making computer art early on are mathematicians and physicists. So it's kind of an interesting connection with data art. And then personal computers show up in the 70s, and everyone now has access to this stuff, and you'll see computer art start to explode. I want to make a distinction right here about the difference between computer art and data art, okay? So data art isn't necessarily computer art, right? When I talk about data art, I'm talking about art in which data is used in the creation of the artwork at some point. Generally, this is done on a computer, but there are tons of examples where you can have data art without a computer. And the example I like to give is there's a book called Dear Data by Georgia Lupi and Stephanie Posavec, and I think they're like designers, and one of them lived in New York City and one of them lived in Paris. And what they would do is for a year, every week, they would visualize something. I'll show you this later on, but they would visualize something by hand on postcards, and they would mail them back and forth to each other, and they put the whole collection into a book. No computers, but it's definitely data art. So they would do things like they would track for the week, like by hand, how many doors they went through and what kind of doors they were, and they both visualized it in some way, and they would send the postcards to each other, and they got to see how each other visualized it. It's pretty interesting. And then I say, though data art and computer art are very closely related, because maybe not most, but a lot of data we manage with computers, and so it's sort of a natural marriage between data art and computer art. But you can also have computer art that is generative art, that doesn't use any data, it's just randomly generating numbers from algorithms. I would not consider that data art, though my wife disagrees with me, and she's right. I love looking at this camera. Okay. Context is important to thinking about art, and technology is important in thinking about, and technology has always affected art. So let's think about now where we are right now. We live in a big data world, right? Every second of the day, I'm walking around with a device that's tracking my location. I'm walking around with this thing that's tracking my heart rate, and this is all being sent to some private company, and we shouldn't be doing this, but it's happening, right? There's data everywhere. It's constantly around us, and we can't get away from it. That's the context in which we're living, whether we like it or not, okay? And in context, as a society, we haven't really yet fully understood all the implications of living in a big data world. So there's all this technology that's generating all this data on a scale that we're generating data on a scale that is so large, we don't have the statistical methods to analyze this data. There's a whole bunch of people who are working on just developing methods statistically to handle all of this data that we have. Like if you go back, to the 1950s, the methods we have for analyzing statistical data, you always assume that the number of observations is much larger than the number of variables, because how could it ever be not that? And then all of a sudden you have genetics, and you have very, very wide data sets, and it explodes. And there aren't methods, because they didn't need methods to do that. So the world in which we're living in and the technology that we have, I'm arguing correctly that it inevitably leads to data art. Data art is not just a like kind of neat thing that's happening. It's a real part of art and real part of art history. right? And some of these works that are being created by these data artists are actually they're in collections at actual museums, like the Museum of Modern Art in New York, and the Art Institute in Chicago has work by data artists where they're realizing this is a really important thing about art, not just data art, but like it's important for art in general, and they are putting them in collections. It's incredible. Okay, I've convinced you now that data art is something that is important, it was inevitable, and is an important part of art today. So in thinking about all that, now I'm going to do like a history of data art, because we're here now, let's talk about data art. Okay, so I break it down to pre-2000 and post-2000. I don't know if that's a good delimiter, but we've done that. So I start with this. This is by Menard, right? Charles Joseph Menard from 1869. This is the Napoleon's March. Now, this is a data visualization. It's certainly a data visualization. Is it data art? I argue that because of the way in which it is displayed and how it's been used over and over again, that it can be displayed as data art. But you could disagree with me on that. That's totally fine. I sort of start with this as data art, mostly to say that the person who's famous for this is Tufte. Tufte didn't do it. I want to remind people of that over and over and over again. This is not Tufte's work. It's Menard's work. But Tufte sells a bunch of these and makes a bunch of money on them. And I don't like it much. Okay. So this is way back in 1869. And then you get to this right here. And I saw the book in your library. You have this book in the little library downstairs. The Exhibit of American Negroes by W.E.B. Du Bois. This is work displayed at the Exposition Universelle in Paris in 1900, and it was called A Georgia Negro, A Study, 1900. And he hand drew all of these incredible graphics about what it was like living in America at the time as a free black person. And so these are all hand drawn, and they're data visualizations. Now, if you want to argue that the Menard one was a data visualization and not data art, I'm mostly with you on this. I'm arguing, and I probably wouldn't agree with you if you push back on this, this is data art because the way in which it was displayed was they put them all together in a booth at the World's Fair, and they were being presented as a collection to get you to think about what life was like for this group of people at that time, right? And I think this is very effective data art, okay? It's an example of when data visualizations, which these are, can really become data art, okay? I love these. There's a book. If you've never seen this book, go downstairs after this is over. You're in the basement? You're in the basement. Go to the basement and go to their little library, and this book is there. And just flip through it. They're incredible, and they're all hand-drawn. Okay. So then we kind of fast forward, and these are early examples of computer art, okay? So I show these to show that this is what computer art looked like. These are not necessarily data. This is not necessarily data art. These are two works from the 60s and the 70s. This is Frieder Nake, and this is Homage à Paul Klee. If you're familiar with Paul Klee, he was an artist, and this is Frieder Nake was trying to make something in the style of Klee, and he made this with a computer. And then you have this by Paul Brown, and this is Untitled Computer Sisters Drawing 1975. The reason I include these here as not data art, I want to show the difference between computer art and data art, but also I could make this on my computer. I could make this on this thing that I carry in my backpack. I could make this in probably, or something like that in, I don't know, 10 minutes. I would need to figure out what the code is to do it, but you could probably write code to do this and generate this in 10 minutes. To the context here, though, this was done in 1975, right? To create that with a computer in 1975 is really interesting, whereas to create that in 2026 with this, it's not that interesting, all right? Or even if it is interesting, it's a totally different meaning that it was made in 1975 versus 2026. Okay, and then that's the other one by Paul Klee. But these were again, they're made by computers. That one's from 1965. That's crazy. All right. So here this is I think I remember coming up with this example of data art, and I was like, oh my God, mind blowing. This is a really, really powerful example of data art. So this is the Vietnam Veterans Memorial. This was created by Maya Lin in 1982. If you've ever been to this, or if you know what it is, or if you don't know what it is, I'll explain it. It's the Vietnam Veterans Memorial, and all of the names of it's anyone who was missing in action or a prisoner of war their name is printed on these like granite slabs, and it's very shiny, and you can see a reflection in it, right? And if you just built a monument to like the Washington Monument or the Lincoln Memorial, it's one thing, but it's another thing to see the scope of how many people were killed in the war. And so you're actually visualizing, you're presenting a visualization of how many people died in this war, and you can see it sort of from a grand scale, right? You can see based on the size of it, you can see how many people were killed, but it's also, you can go and see the individual names. And so you're getting kind of both these pieces where you have the macro scale where you can see the vastness of how many people were killed in this, but also everyone is a name. And what I really like about this piece is that it's reflective and you can see yourself in it, right? These people were parents, they were kids, they had brothers and sisters, right? And that's who you are, right? You're seeing your reflection in this wall, and they were just regular people like us, and they all were killed in the Vietnam War. This is also done chronologically, right? So not only is it a list of the names, but it's a chronological list of when they were killed in action. And so she's really leveraging this idea of data visualization in the data art piece. And the other thing I really like about this is that it's actually a kind of a V-shaped, and you start out here, and it starts out very low, and you go down into it, and then you come back out of it, right? And it's following the timeline of the war, right? Because they're done chronologically, you can walk along, and you can see where everyone in time, where all these people were killed during the conflict, and it goes down and comes back out. If they weren't in chronological order, it would have a different meaning, right? But she made these really conscious choices to make this really incredible monument, and it works because of aspects of data visualization, right? It's really incredible. And you should go read about, there was a contest to figure out what they were gonna do for a Vietnam memorial, and she submitted and she won, and people hated this at the time. And there was a whole big thing about it, and then she did this, and everyone agrees now, this is incredible. What were we talking about at the time? This is an incredible piece of data art. Okay. This is not data art, but I'm showing you this now to get to a point where that is data art. Tree maps are something that was invented by Ben Schneiderman, and this is a tree map, and he was a computer science professor, and this was used to visualize like the hard drive of your computer, okay? And he did this in the 80s or whatever, but he then, in 2014, took this idea of tree maps, and he took data, so this is called a series called The Singing Mondrian. He took data from Last FM, which was at the time the big music service. Think of like Spotify now or whatever, Napster for anyone who's my age. He visualized each one of these, the size of these squares are how many times that song was played, and each of the colors represents a different genre of music, and he did it in the style of Mondrian, who is a Dutch neoplasticist, if you know anything about art history. Okay. These works, the collection of these is actually in, I believe this is in the New York Museum of Modern Art. I believe they have this collection of works, and it works because it's data art, but he's also referencing an artist from the past, right? He's like having this conversation with an artist from the past, and he's doing something very modern, a streaming service, and he's using these tree maps that were made for computers. He's like taking stuff from the past and he's updating it to present day. Okay? So that's sort of my pre-2000 stuff. Okay. So 2000 to present, now almost all of this stuff is going to be computer related because that's sort of where we are post-2000. So this is a work of art that not only is this not paint on a canvas, this isn't even really visual, okay? This was made in 2004, I think it started. Well, he's got them up there. 2005, I think this started. This is done by an artist named Hassan Elahi. And what happened was 9/11 happens, okay? And Hassan Elahi I believe he's a Pakistani man, and he had an experience where he was targeted at an airport when he was going through security. I don't know if that's true, but it was something like this. He had an experience where he was unfairly targeted, and he realized that he was living in this surveillance state. And so what he did in response to that was he goes, if you're going to surveil me, I'm going to overwhelm you with data. And so what he started doing was he started taking pictures of just everything that was going on in his life. He would take pictures of what he was eating. He would take pictures of where he was going. He would take selfies, and he would just post all this online, and he would like overwhelm. He was like, if anyone's tracking me, here's everything that's happening. I'll track it. Instead of you tracking me, I'm going to track myself and just throw it all out there, right? And so here's some examples of this. These are like photos that he would post, and there are literally like thousands and thousands and thousands of these photos, and he was just doing this every single day for a decade, okay? He has a picture of a bus, he has a picture of the meal, he has a picture of the urinal, which I like to think is a reference to Duchamp and how absurd being tracked like this is, right? I don't know if that's true, but like that's what I take away from that, is that's the reference that I think he's making, or maybe I want him to be making that reference, but these are like examples of the photos that he was taking, like just absolutely mundane stuff, and he would put the date and time that they were there, and he was like, if you're gonna track me, I'm gonna track myself, which is a great move, I think. Okay, but like the art here is like it's not one, like you can't display this as a visual, it's the whole project that is the art, right? He had this website, the art is the entirety of this collection in the process. It's performance art in a way, right? He's just taking all these photos of his everyday life and he's posting them on a website, and that becomes the art, right? It's definitely not visual art in the same way that we would think of it as in a museum. Okay. Speaking of museums, what an incredible transition I just made. So true story, I was at the Art Institute of Chicago, as I do, because I'm a sophisticated, cultured man, and I was walking around, and I remember being in sort of there's like this basement area, and I remember looking across the room and being very visually drawn to this piece. I didn't know what it was, but I was visually drawn to it. I walked across the room, and I looked at it, and I read its description. And then when I read its description, I was like, oh my God, this is even better than just liking it visually, right? And that's what I like to try to do when I create data art, is I like to try to create something that is visually impressive by itself, and then when you find out how it was made, it's even better. And this is like a real experience that happened to me. This is by a guy named Jason Salavon, who's gonna show up a bunch more times, and it is called the top grossing film of all time. It was at the time, it was Titanic, now it's one of these Avatar trash movies. James Cameron, your movies are trash. Get that on video. Okay, so this is every frame here. It's every frame of the Titanic, and he took each frame, he took the average color of the frame, and then he laid them out from left to right, top to bottom, and this is the whole movie sort of visualized. But he's using the frames of the movie to generate a color, and then he's laying it out as data. He's using the images as data. And then, spoiler alert, they sink. See? That's where they sink. Did you guys know that? Okay. All right. I think it's funny. Okay. Same guy, Jason Salavon. This is from 2002. He was really interested in working with this stuff in the early 2000s. He was like taking a bunch of images and like sort of trying to average them together. And so what he did with that last piece was he was averaging the entire frame to get a single color. What he's done here is he's taken, these are Playboy centerfolds, and he divided this by decade. And he took all the centerfolds and he sort of averaged the images. He stacked them all on top of each other, and then he averaged all of the images on top of each other. And what I think is really interesting about this is that you see that not only does the background color change, but like the skin color changes, the hair kind of changes, and like even the shape of this changes, right? He's sort of getting these, there's like these ghostly images of like what it means to be sort of like a sex object in those different decades, and they can see that it's changing over time. And this is my interpretation of it, doesn't have to be yours, but like when I see this, what I think about this is that like there's this idea of, you know, a pornography magazine, the idea that these models are just completely replaceable, right? And I think that's what he's getting at here, is that like they don't have faces, they're just the next thing, right? It's this like replaceability of the model, and it's not even about who the person is, and they're sort of, I don't know if that's anywhere near what he was meaning, but like that's what I take away from that. And I think it's absolutely like beautiful by itself. If you had just seen this by itself, I think it works well, and then when you realize how it's made, it's even better. And that's what I really like about this guy's work. I'm a little bit of a Jason Salavon stan, I'll admit it. I love this guy's work. So that was Jason Salavon. There's another woman named Natalie Niebach who made some sculptures. So look, I'm trying to show you all these different things. These are data art sculptures, okay? These are made by, this one is made with weather data. I have two examples here. This is weather data, and this right here is Hurricane Noel. Both of these things, she's taken weather data, and she has like sort of mapped each of these components of the weather data to some aspect of this sculpture, right? And so she made this one right here, and she also made this one right here. There's something like, I don't know, winds. I'm probably completely making this up, but I believe the little balls on top have something to do with wind speed, and there's some temporal aspect to this. I don't know exactly what they represent, but these are data art sculptures. I would also like to take this up, and I don't mean this to be critical of Natalie Miebach or anything. These are examples of data art that I think are very successful pieces of data art that I don't personally like. And so one of the things that my wife has gotten me to do is think about, is this piece of art successful or not? And do you personally like it or not? And those are different things. And so she's got me to think about this, and I'm trying to get you to think about it. I think this is very successful data art, but I wouldn't put this in my house or my office or wherever I would put art, okay? And that's fine, it doesn't matter. People have different opinions. This is work by Mikami Yoshiyuki, and she was creating visualizations for the World Wildlife Fund, not the WWF. They got sued, they're the WWE now. She took images of animals that were endangered, and she pixelated them, and the number of pixels that she was using were approximately the number of animals left in the wild. So you can see over there, you have the African wild dog, there was about 3,000 to 5,000 remaining, and then you have in the middle, you have the Amur leopard, which is only about 20 remaining. And so what I really like about this is that you can, by the smaller the number, the more pixelated it gets, and it's like they're disappearing, right? That's a powerful message to be made with this piece of art, where you're literally seeing it disappear because you don't have enough pixels, right? So she's asking a really great question. Are we just gonna let these animals go extinct? And she's visually showing how extinct they are by using the number of pixels. And they're like, you can literally see like the tiger is disappearing on the right here because you're losing resolution in the image. I really like this stuff. Okay. These are by, this is called Time Blocks by Lori Frick. Again, this is another example of something that's not made with a computer. This is data art that is essentially a sculpture. This work, and I think the next slide, these next two slides are based on, two different things, but they're based on how people spend their time. This particular piece, Time Blocks, is based on, there was a guy in New York City who took very detailed handwritten notes of his life, and he was on a 28-hour clock. So he would his circadian rhythm or whatever it was that he would wake up and then he would go to bed, but that whole cycle took 28 hours. And so you can sort of see that if you look at the colors, there's sort of a shifting where each one of these blocks represents 24 hours, but there's sort of a shifting where he's shifting his day, where sometimes he's nocturnal and sometimes he's awake during the day, right? And so she made this based on that. She just liked this, she liked this set of data. This right here is based on, I believe this is based on the American Community Survey's, the US Census American Community Survey data of how Americans spend their time, okay? And there's 7 of these things, and it's called 7 days because it's a breakdown of the days. So I believe it goes from Sunday through Saturday, and then each one of these little blocks right here is some fraction of time that Americans spend doing this particular activity. She is color-coded. She's color-coded different activities with different colors, and then I guess the stuff at the top is sleep. That's what I would guess. And these are, I would put this in my house. I like this for what it represents, and I also like it visually. And I was able to actually see this work. There's something called Expo Chicago, and they get a whole bunch of artists to come and display their work. And I remember walking around, and I stumbled across this, and I was like, that's Lori Frick's work. It's pretty cool. So this is another example of data art that is not made with a computer. It's a sculpture, right? Or it's hanging on a wall. I don't know if that makes it a sculpture, but. Okay, all right, this is wild. So this is another example of data art that is not just a visualization. So here's what this woman was doing. So there's this woman named Heather Dewey Hagborg, and this was like 14 years ago, 13, 14 years ago. She was going around Brooklyn and she was picking up pieces of trash, like used bottles or used cigarettes. She was taking those things, or chewed up gum. She was taking those things. She was going to her friend's lab and she was sequencing the DNA. And then what she was trying to do was she was trying to recreate the face of the person whose DNA she found on the discarded trash. And so she created these things right here. So this is the face that she tried to create, and she has a picture of like where she found the cigarette butt. This is the thing that she used, and then there's some information about that individual. Think about this. This is 15 years ago, okay? At the point when this was made, the faces that were made were described as they might have a familial resemblance. But this was 15 years ago. At some point, who's to say that we can't actually reproduce the entire face from DNA? I don't know. That's a crazy thing to think about, though, right? Like, I'm drinking from a straw right now. You could go swab that and figure out what I look like. We have not really dealt with this as a society, that's something that's even possible. I think most people don't think about this. What I really like about this is that she isolated the face. She didn't put hair on them, and she didn't put a body on them. It's just the face. Because more than any other part of our body, our face is who we are, right? Your identity is not your hair or any other part of your body, but we recognize each other as a species based on your face. She's really saying, look, I can figure out who you are by your DNA that's on a discarded cigarette butt. That's crazy. That's deeply unsettling. And here's another example of a guy from a cigarette butt again, and these are from Brooklyn, New York, right? But it's crazy that you can even get close to this, right? This is something that was not possible 20 years ago, 30 years ago. It's crazy. I talked about this before. This is an example of Dear Data. These are the postcards that they were sending back and forth to each other. So this is Georgia Loopy. This is Dear Data week 24. This is a week of doors. So she's coded, this is her key right here, and she has coded what kind of doors she's been going through, and then she has drawn them all up on these postcards, and they were sending these postcards back and forth to each other. This is a data visualization, but also the way in which they are collecting this and putting this together, it becomes like a performance art kind of thing because they're sending postcards back and forth to each other. How long do you want me to talk for? So 15 more minutes? Perfect. Okay. And this is Stephanie Posavec's version of that, where she coded doors slightly differently, and you get these postcards. And there's a whole book on this, and I highly recommend it. And it's every page is like a week of the postcards that they sent back and forth to each other. You should get that for your library. Okay? Data art, not necessarily made with a computer. This is on, you may have seen this in the basement. This is by Charlotte Wickham, and she made this for the JSM Data Art Show. And this is from her Root series. These are created by taking, she's like picking a starting point and an ending point, and she's putting it into Google Maps. And then she's taking each frame of that journey, and she's taking a clustering algorithm, and each one of these slices is the distribution of the colors in that image, right? And then she runs it from left to right as you go on the journey, and so that's why it's called the Root series. I have one of these in my office, which is from Springfield, Massachusetts to Chicago, where I grew up as a child, and now where I live now is in Chicago, and I love it, and it's in my office, and I look at it every day. And that's Charlotte Wickham. Her brother is Hadley Wickham. They're a deeply data statistics family. She's at Oregon State, I believe. Okay, now we get to generative adversarial networks. So in 2014, so this is like everyone wanted to do this in 2014. So in 2014, this guy, Ian Goodfellow, proposed this idea of generative adversarial networks. These are called GANs. The idea of a GAN, if I can describe it as quickly as possible, is that there's two things. There's a generator and a discriminator. The generator is just generating a whole bunch of stuff, and the discriminator is saying, that's real, that's not, okay? And there's a loop that goes back and forth where the generator generates a bunch of stuff, the discriminator says, I think that's real, I think that's fake, and then the generator gets that information back and goes, okay, you think that's real? I'll make more stuff like that. And then it goes back to the discriminator and it goes back and forth until it's able to generate real-life looking things. And so this is kind of terrifying in a way because you can completely generate fake new people, for instance. But it took a while to get to that point. In 2014, the first iteration of this was, you could tell it wasn't human faces, but now we're way past that. you can completely generate fake whatever you want as long as you have a training data set to train it on. So this is one of the first pieces of art that was made with, I don't know if it was one of the first pieces, but it was one of the first pieces of art that gained sort of media attention that was made with GANs. So that paper was proposed in 2014. This is work from 2018. This is called Portrait of Edward Bellamy. It's from a Paris-based arts collective, which is like the most obnoxious phrase in the world, right? And it was made in 2018. Someone programmed a GAN, and then they were generating a bunch of images from it, and they chose this one to be their final piece of art. This is not a real person. They never existed. It's just a generated piece of art from this trained GAN, and this sold at an auction for like $300,000. Maybe, I don't know the exact amount. Maybe it was $500,000. Hundreds of thousands of dollars that this was sold for in 2018. And people had a lot of questions like, who's the artist here? Is it the machine? Is it the programmer? Is it this collective? I don't know. You figure it out. Let me know. So this was GANs. And then a whole bunch of other people started using these in their work. This is a still from a video by Mario Klingemann. How would you say that? Klingemann? There's something called Memories of Passerby 1. And there's a video, you can go watch the video of this, but in these GANs, you are basically, there's an input vector, and that every input vector maps to an image. And you can slightly change that input vector, and you can sort of smoothly scroll through the space of these images. And they make these really haunting videos of like sort of faces. And so go watch this video. It's really incredible, but it's the idea of them scrolling through this space of these images, and you get to see what these look like. It's really, really interesting. This is the same guy. This is Mario Klingemann. This is me. I've failed. Don't pay me. I've failed. It's a typo. This is the Butcher's Son. This won some award. This won some prestigious award in England in, I'm going to say 2016. I think that was the year. This is completely generated with a GAN. And he wanted to create an image of sort of a nude person. So what did he train it on? What would you train, what data would you take and train on to produce the image of a naked person? Pornography. He was taking pornographic images, and he was using those to train on them, and he generated this, and it's basically the image of a naked, it's roughly the image of a naked man, I would say, but it's like really, really bizarre looking, right? And he's creating this with a computer. So here's the thing, my wife, she doesn't think this is data art, and I'm like, I disagree with you fully on this. The input here, the data that is used to create these are the images, right? There's different images that get fed in. There's images that get fed in, there's an algorithm, and there's an image that gets spit out. That's data art, right? That's not simply generative art where you're generating random numbers to make images, which is something you can do. There's data here, right? An image is literally just a three-dimensional array where you have X, Y location, and then you have 3 color channels. Every image is just this three-dimensional matrix, essentially. It's just numbers. It's literally just data going in, you're running it through an algorithm, and it gets spit something out. So I absolutely consider this to be data art, even though my wife does not. You're right, honey. She's going to watch this. I've never called her honey in my life before, though, so that's weird that I just did that. Okay. There's my boy Jason Salavan. So he was doing something with GANs. And this is from a video called Genmo, and it's called Sampler. And there's a video for this also, and he was trying to make faces with other objects, right? So he's making faces here with like a hamburger as the mouth, and you have cats as eyes, right? So he's trying to make sort of images that were faces from other images. And Jason Salavan is like I make art and it's fun, and like some people like it. Jason Salavan's like an actual big time artist. He has work at the Art Institute of Chicago. He also, in every like holiday season, they will let people project work on, this is a building called Merchandise Mart in Chicago, and it's this very, very large building. And during the holiday season, they'll project stuff onto this, and they'll have these like big light shows. And Jason Salavan got a day where he created something with GANs, and he projected the video onto Merchandise Mart. And so that's a still from that video, and then you have his assistants. This is by Anna Riddler. This is a still from, again, these are videos. Just like the other GAN videos that I've only showed stills of, the input data, the images, depending on what images you put in, you're going to get different stuff out. So that the butcher sum was trained on pornographic images. These are trained on open, I don't know what it's called, but when stuff loses its copyright after like 99 years, whatever that's called, these are trained on old images of Hollywood films. And so this is a still from an old Hollywood film, but if you watch this video, you can see like, you'll have a frame where it has like the caption, because they didn't have sound, and it's not real words, it's just things that look like words. Because it's trying to generate things that look like that, but it's not quite getting it right. And so this video is like really, really, if you're gonna watch one video from this, I would watch this one. And it's like very clearly an old video, but it's not quite anything you'd recognize because she's using a GAN. These are from Tom White, who I personally like very much. What are we doing? Okay. So Tom White is he's an artist from I think he's from New Zealand. I have a bunch of these in my office because I love them so much. He was taking images, he was trying to fool an AI classifier. So he was like he wanted to create an image that a classifier would say, oh, that's this object. So as an example of this, and once again, that's the third toilet in this talk, which is an incredible amount of toilets. And he's saying this is not a toilet. That's a reference to Magritte, the famous French surrealist, René Magritte, Son of Man. Anyone? Look it up. And so this image right here, if you pass it into a specific AI, machine learning classifier, it would classify that as a toilet, right? And he's referencing Magritte by saying this is not a toilet. And he has a whole series of works for this. This is banana. I have this one in my office because I'm an avid art collector. Because as I said before, I'm a sophisticated man. So that's banana, and then I thought I had another one here. Well, I guess I don't. But he has a whole series of these. I also have rabbit in my office. But he did like dozens of these things, and they're all screen printed, and I love them very much. And I hope they go up in value. This is by a guy named Dries de Porter. This is from 2020, like COVID-ish. This is a clock. You can I don't think you can buy these anymore, but you used to be able to go to this website and you could buy a clock, and you could pass your birthday in, and he would create a clock for you that told you how much life you had left based on like life tables. Based on your average life expectancy of who you are, it would tell you what percentage of life you've lived, right? So the data that they're using there is when you were born and information about the expected life, the life expectancy of individuals in the United States, right? I don't know if I'd put this in my house either, but it is certainly data art. 57.3%. And I'm going to end here with, I have a few more that I want to show you before the end, before you kick me off your campus. This is from 2021. This is very, I think of this one as very similar to the Vietnam Veterans Memorial one in terms of the scale here is what matters. So what this woman did here is Suzanne Brennan Furstenberg. This is in 2021. You guys remember COVID? She was planting these little white flags for every COVID death in the United States. And so this is the National Mall, right? You're not going to convey the sort of scale of the death if I just say 200,000 people died. But if you see white flags covering this entire field, that feels very different than seeing a number, right? There's something very different about hearing large numbers and saying this many people died, and you go, I can't really picture that, but like visualizing how many people that is, it conveys the information about how many people it was very differently than a single number, right? And it should make you feel a certain way. There should be some reaction, unless you're like a complete sociopath. You should have some reaction if you go to the Vietnam Veterans Memorial or if you see this much death represented in these little flags, right? It's really, I think, powerful in showing it how grand a scale the death was in those two events that I've highlighted. So this is very recent work. This is work by Karel Benzi from 2020. This is it's called Together. This is a visualization of a company. So this is like the CEO of the company, and then it's all the people who are sort of underneath that person and all the connections that they have. And they made it look like, they made it look floral almost. So this is an example of, I really like this on its own, and then the way that it was actually created, I think, adds to the piece. This is literally just someone I found on Facebook. I have no idea anything else about them. I think they just made this at their house. But this is a 365-day temperature study. It's from 2023. This is, the color is the temperature, and then the band is the daylight hours. And so they just made it it's for a single year, and I love it very much. And you can see the shifts where daylight savings time happens, and I think it's really nice on its own, and it's data art, and I love it. Okay, and here's where I'm going to end. I'm going to end with this last person because it's very, very recent. We've come all the way up to the present day. This is a still from another video by this guy named, I'm going to say Rafiq Anadol. That sounds right, right? This is from Machine Hallucinations, and if you look up there, this is Machine Hallucinations, MoMA. His work is in the collection at the New York Museum of Modern Art. This is not just data art, this is like art, right? They're collecting art that they think is relevant, not because it's data art, but because they think it's relevant, okay? His work actually is it's the first work that, what do they call them on the blockchain? He has work that exists on the blockchain, and the Museum of Modern Art purchased his work on the blockchain, or whatever blockchain he's on, and it's the first work on the blockchain that they've ever purchased, right? So he's like a big shot artist, and he's such a big shot that he, I didn't scale it right, but he designed the cover for Time magazine, and this was from September 8th, 2025. So this is like last year. Time magazine is, they have the Time 100 AI. It was about the 100 most influential people in AI, and they had this artist who they listed on this list, and they had him design the cover. So you can sort of see since 2000, there was people who were making data art, and they were sort of in their own little world. But data art is like becoming mainstream right now. This is from a few months ago. This is on the cover of Time. And what he's doing is he's using GANs here, but he's using GANs of the data that he's feeding into his GANs are like landscape images. So he's really interested in like creating these organic looking videos. But he has work that's displayed all over in all the big time museums, and he's like a big shot, real time artist. He just happens to use data as a medium. Incredible. So I'm out of time. I'm going to finish up. I have a whole bunch of stuff here. This is my shameless self-promotion. But what I want to show you is I've created some stuff here. That's my GitHub repository, and there's a repo there called Mondrian. I've given this talk before, and one of the things that we did was this activity where they took that code, they messed with some parameters, and then they made these images, and we printed it out for them, and they all got to go home with some nice little piece of generated art. There's a website, which I didn't add the link, but there's something called January, where every day of January, there's a prompt, and it's asking you to make generate art based on this prompt. So like the prompt might be explore transparency or Fibonacci sequence, do something with a Fibonacci sequence. And it's incredible practice. I've been trying to do them all, but life. But it's incredible practice. Just go make something based on these prompts as practice. And then, nope, we've lost it. The last thing I want to talk about is that there's a big statistics conference called the Joint Statistical Meetings, JSM. And since 2016, when it was held in Chicago, I convinced them to do a data art show at the venue. Well, that's not how it happened, but they had a data art show at the venue. They've been doing this every year, and it's still around. And I want to get every one of you to think about submitting work to the JSM Data Art Show. That's where I met, some of the people who are displayed downstairs. Kenny Vaden, I know through the JSM Data Art Show. Charlotte Wickham, all those people. Make art and send it to me, and we'll put it up at a conference, and people like that stuff. If you want, I'm happy to show you. We'll stop the talk. I'll stop talking, but if you want, I'm happy to show you some of the stuff that I've done in sort of without without the camera because this guy's probably got to go somewhere. But I think that's it. Yeah. Oh, we got to do Q&A. I forgot. We got to do Q&A.
Hi, sorry. I'm so sorry I missed the beginning because I had to be somewhere else. So you might have already answered this, but what I find, I think, the most fascinating about the idea of data art is like the tactility of it. Like data art as opposed to like a data visualization is something that you can feel and like walk around in a 3-dimensional space. So do you have like, I don't know, feelings about what that does to data or what it does to the interpretation of data? Do you have a favorite medium that you like to look at? I'm also sorry that I am an art person and I'm probably the only one in here, but I think that the medium are really cool. And that's, I don't know if you have thoughts about that.
So you're asking, you're saying that you like 3-dimensional art things.
Yeah, so like, do you have thoughts about the ways in which making data tactile and physical affects the ways that people interact with that data? I mean, obviously in a physical way, they are interacting with that data, but in a like an emotional way, in a call to action way, in an interactive way, I don't know. I didn't really have a question, but I wanted to like pick your brain about this idea.
So do I have any thoughts about that? I guess no is the answer to that. But I think there are people who are, I'm trying to think of an example of this. The idea of interactivity of the data art. I've seen, I'm at the stage in my life where I go, I've seen this somewhere and I don't know where it is and I'm just not going to get it back, but I've seen some data art where the data that's getting passed in is the individual interacting with it, where they'll like walk up to a screen or something, and then the output is interacting. The output is being created by like your physical being near there, and yeah, I think that's a lot different than a static image displayed in a traditional like museum setting, like the Titanic thing. Yeah, I agree with you.
Sorry, I did not prepare that question very well.
I get nervous around the art people because I'm a stat person pretending to be an art person. Thank you. Did I get the art stuff right?
Yeah.
Okay.
So I actually have more of a comment. I actually teach something similar to this, again, to these high school students. So I just was going to comment that there's a fabulous book called Record, Map, and Capture in Textile Art, Data Visualization in Cloth and Stitch, which is a whole branch of work that's being done around using weaving and cross-stitching and various representations of art. Similar to Natalie's work, in other words, taking a data set and then using it to make a representation versus using sort of the computer as like an AI-generated type thing. So they're kind of two different ways of making art.
It's textiles?
Yeah, so in fact, we teach an entire course on using textiles to represent data. Yeah, so there's a whole...
Really? That's
yeah,
incredible.
you don't want to, if you think you could talk forever, Patrick knows I can talk forever, so this could go on for a long time. But if you're interested, there's a whole history of this. Like, for instance, there's women in the Second World War who used to actually knit, and like the way they were knitting, they were actually sending a code as to like how many German trains were going out their windows. So it starts like in that kind of way of textiles. But yeah, there's a bunch of artists who use things like cross-stitch to represent women's work. And so they do a lot of representation, of looking at the labor distribution, but using cross-stitch deliberately to sort of do that. Very similar, I mean, they're all kind of in that type of Natalie Maibach's work, where it's something where you take a data set and then you represent it. Lots of weavers, lots of textile artists, yeah.
What type of data sets are they using, like, more contemporarily?
So these are all contemporary artists. These are all people from, like, the last 5 to 10 years.
So what data sets are they using?
So they look at employment data, for instance. Like if you look at the distribution of women's work, how much time per day do women spend doing paid work, unpaid work, various things like that, versus how much time do men do. You can find this data in various employment type data sets and things like that. So yeah, so then they do various binary codes, using beading and a variety of things. But if you're interested, this book is really the best source to sort of start the exploration, and I'm happy to send you more information.
Well, I'm going to steal it and add it to the talk and then say I found it.
That's why I recommended it.
Good artists borrow, great artists steal. Right? You know, Picasso? I want to have a camera all the time. This is great.